All right, so here's a type of an example problem that you might run into with your next assessments for the circuit problems in learning objective number 1. So here we have a circuit. We have these 4 resistors connected as shown. We have a battery that has a 60 volt potential difference, and we're told that the internal resistance of the battery is 0. That's kind of how we've been working. We've just been ignoring that idea of the internal resistance. So it's kind of information that we shouldn't even really worry about. I'm just going to redraw this just to make it more obvious to me, the relationship or the arrangement that we see in our picture. Because really what we have is a set of resistors that are connected in parallel, and then those 2 parallel groups are in series with each other. So I wanted to just draw them. Sometimes it's really helpful to redraw a circuit in a way that the relationships or how things are organized is more clear to you. And so that's what I like to do a lot. Sometimes they try to trick you by drawing resistors at a certain location to make you think that they're in parallel, but they're truly not. And sometimes it's just not as obvious. So that's why I wanted to redraw this particular one. Now the first thing I'm going to do is I'm going to look at these 2 resistors that are in parallel because I want to simplify them. I'm going to say it's 1 over 3 plus 1 over 6 is 1 over whatever the equivalent of those 2 are. I like this problem because the numbers all work out really nicely. So I'm just doing my common denominator here, and I find that the equivalent resistor to those 2 in parallel is 2 ohms. Now I'm going to look at these 2, and I'm going to get 1 over 12 plus 1 over 4 is equal to 1 over the equivalent of those 2. Again, I can use my common denominator. And I find that the equivalent resistance of those 2 resistors is 3 ohms. So I'm going to redraw my circuit because I really like to do that, because then it helps me just think about how I go backwards when I start to try to find potential differences and currents through resistors. So I've replaced these 2 set of parallel connected resistors by just 2 individual resistors. This one has a resistance of 2 ohms. This one has a resistance of 3 ohms. My battery is 60 volts. When these 2 are in series with each other, as they are, we simply add them together to find the equivalent resistance. And now we can write this circuit, which was originally 4 resistors connected, as a single 5 ohm resistor connected to our battery with a potential difference of 60 volts. Now I'm going to find the current that goes through this particular circuit, the simple one, with 60 volts over 5 ohms gives me 12 amps. So I have 12 amps that go through this circuit, which means I'm also going to have 12 amps going through these 2 resistors that are in series. So they both have a current of 12 amps. And then I can also, I'm using Ohm's law a lot, so let's just write it down. I can find the potential difference across these 2 resistors. This is 24 volts, and this is 36 volts. Now when I move back to the circuit that they were taking the place of, what kind of information remains? Well, we remember that the potential difference across these 2 resistors that replaced the resistors that were connected in parallel has to be the same. So these both have a potential difference of 24 volts. This is 24 volts. And the potential difference across the second set of resistors connected in parallel is 36 volts. And then finally, now that I know the potential difference across each of those resistors, I can use that to calculate the current that goes through them. Again, that would be the potential divided by the resistance. So this ends up to be, this is 3 amps, and this one is 9 amps. And notice that 3 amps and 9 amps adds up to 12 amps, which is this current right here, so that makes sense. If I move over to these two, the first two that are connected in parallel, the potential difference across those was 24 volts. And so if I use that to figure out my current, this is 8 amps and this is 4 amps. Again, the two add up to be 24 volts. So again, here, this was, I'm sorry, 12 amps. So 24 volts was across this connection, 36 volts was across this. Notice that they add up to equal 60. My currents in each of the branches is found using Ohm's law and my potential difference. Notice that when I add my currents to the resistors in parallel, they add up to 12 amps, which was my total current through the circuit. Everything works out really nicely. I love problems where they give you numbers that work out well. So hopefully this is helpful.